Hi, what's up guys? Welcome to my video again. And today we're going to learn about access control list, and today's October 26th and this is second semester in cycl5. Well, cycl5 is with chapter 1, 2, 3 in the second book, and it's all about access control list. Chapter 1, Introduction to TCP/IP Transport and Applications. So TCP/IP is Transmission Control Protocol and Internet Protocol. It is Internet Communications Protocol. Basically, it is for communications protocol in a computer network. So, what is UDP? User Datagram Protocol is communications protocol used for establishing low latency and tolerating connection between applications in the internet. The difference between TCP and UDP is that TCP provides a wide service to applications, but UDP doesn't. It means TCP provides retransmission when there's any error. It covers and helps to avoid congestion. But UDP does not have that function. So, this picture shows that Hannah, hi Hannah, is sending packets to George with 3 different applications. One is add data, and wire transfer data, and web page data. However, the point we should check is add data is using UDP and others are using TCP. Those TCP and UDP solve this problem by using a port number in the header so that George can establish different destination port numbers so that George knows which application to give the data. So now, let's get deeper. Hannah is using multiplex, which is also called socket. So, there are 3 socket types: an IP address, a transport protocol, and a port number. So in the web page data, I believe that socket will be port 80. The reason is web servers use the port 80 as well-known port. And for Hannah, when she's using socket, she will use 49160. So what is that? Hannah just needs a port number which is unique only for her. So that's why I chose not 49160. So this picture is using 3 ethereal ports. On the device left and server on right, it is using 2 well-known ports and other user port. Before we get to the point, I will explain what is well-known ports and other ports style. Well-known system ports numbers from 0 to 1023 assigned by IANA. By the way, IANA is Internet Assigned Numbers Authority, with a stricter review process to assign new ports than user ports. User registered ports. Numbers from 1024 to 49151 assigned by IANA, with a less strict process to assign new ports compared to well-known ports. Ethereal dynamic private ports. Numbers from 49152 to 65535, not assigned and intended to be dynamically allocated and used temporarily for a client application while the app is running. I give a full description because I personally think this is important to know. Back to the picture. We can see there are 3 applications together, and the thing we should know is on a single computer socket should be unique, so connection between 2 sockets should identify a unique connection between 2 computers. It means that we can use multiple applications at the same time with different computers. Also, according to the picture, this connection requests from clients are asked to contain both the source and destination port numbers. The port numbers used by the servers must be known before. That is the reason why every service uses a specific well-known port number. So, let's talk about popular TCP/IP applications. First, as we know, www. What is www? World Wide Web. www is very familiar to use because it allows us to access to the web browsers. However, we can actually use www to manage a router or switch. Next, DNS, Domain Name System. It allows us to use names to refer to computers like IP address or client-server model. Another one is TFTP Trivial, File Transfer Protocol. It is just the protocol for basic file transfer, but normally FTP is used by router and switches. It is more functional and do the same work. Okay, connection establishment and termination. Okay, let's see. There are three-way connection establishment. As we can see, there are connection between two devices. And TCP is implied because TCP header is in use. So the only parts of the socket needs to be encoded in the TCP header are the port numbers. Alright, so some of you might be wondering what is SYN and ACK. In TCP header, SYN used in the process of establishing a flag bit virtual line connection, which means a connection setup request, and ACK indicates whether the file is valid or not. So this is TCP connection termination figure, and as we can see, this is four-way termination and also called four-way handshaking. And it is straightforward and used additional flag. It called the fin bit. It is short terms of finished. So the interesting part is before the write PC sends their segment in here, it notified the application the connection is coming down and then wait on an ACK from the application before sending the third segment in a figure. The reason why is that it is waiting for the server to application to reply. Basically, PC on the left sends FIN and write PC tells the application of the closing, finishing signal on the left PC and sending ACK or waiting for the application is finished and send fin and ACK together and close. TCP establishes the connections between the endpoints while UDP doesn't. And there are two terms that we should learn in chapter 1. First is connection-oriented protocol. Very easy, as the word says, a protocol requires an exchange of messages before data transfer and require pre-established correlation between endpoints. And there are three steps of connection-oriented protocol: connection establish data transfer and connection close. Connectionless protocol. This doesn't require any exchange or messages and doesn't require a pre-established correlation between endpoints. TCP is connection-oriented protocol, which means maintaining connection by one. IP and UDP is connectionless protocol. It is not focused on maintaining the connection. It has the address and sending data to destination or router. It is not related with datagram. And error recovery and reliability. TCP provides reliability or error recovery. So, reliability, what is that? TCP numbers data bits should use the sequence and acknowledgement fields in the TCP header. Okay, so I brought a picture and this can explain how to TCP sequence and acknowledgement fields allows the PC to send 3000 bytes to the server. So first, data number is 1000, and each numbers are increasing 1000, 1000, 1000 more than before. So first segment can hold 1000 to 1999 bytes. Why? Because 1999 is the last number because 2000. Easy. So next one is 2 to 2299. And the last one can be 3000 to 3999. Why? Because down below there's acknowledgement 4000. It means it received all data with sequence numbers through 3999, which is less than 4000. And what they're ready to receive is 4000 next. However, what if we face to the errors problem? So obviously there are spark mark and we can feel something is going on the wrong way. The example looks similar, so let's find out. Check on the server part. It says it received 1000 and 3000, but where is 2000 to 2999? The server didn't receive the bytes, and server decided to acknowledge all the data up with lost data. It will send back a segment with the acknowledgement field equal to 2000. So now, server received 2000 sequence and willing to ask 4000, which comes next to the 3000. So the point is that the server can acknowledge not only the resent data, but also earlier data which received correctly. They're making sure everything has been arrived correctly. And now we will learn about URI, which is Uniform Resource Identifiers. As we know, displaying a web page, the browser must identify the server has web page and write contents. Alright, so what I mean is we put www.jack.com. Let's say this is website name and we click in this web page. And what? We see other web page every time we click. Means that clicking action identifies the server's IP address as well as the specific web page. We call that link. And normally people comes with an idea of URL when we're talking about the website and address. What's the difference? URL is Universal Resource Locator. The first protocol of URL is HTTP or sometimes like FTP. It shows the actual network direction and accessing network resource. URI, Uniform Resource Identifiers. It is more correct form, former form, and it used to connect a web server include 3 key components. So this is the structure of URL. Super familiar. So first we have a scheme, authority, and path in formal URI form. But normally we know as protocol HTTP and server's name and web page style, like blog or government or whatever it is. Chapter 2, Basic IPv4 Access Control List. ACL can match packets whose source IP address is blah blah blah, or packets with destination IP. Also, ACL can be used for many ways in iOS. In QoS quality of service features, it allows the router to give some packets better service and other packets worse service. Let's check the picture. It shows the location to filter packets from host A, B to S1. Okay, so we see 4 errors show about data flow right now. Obviously, data flows by router 1 to router 2 by different interface. But what if I enable router 2 fast Ethernet 0/1 down below or either direction? ACL can't possibly filter the packet from host B because F0/1 interface is not the part of the route from B to S1 anymore. So, filtering packet, we should enable ACL on the interface which process the packet. In the picture, if we enable on router 1, which inbound on fast Ethernet 0/0, router 1 would compare every inbound IP packet on F0/0 to ACL to decide packet's fate, unchanged or to be discarded. Matching packets. We should think about the packets we will filter or allow. Also setting up the router with IP ACL matches with packets. Basically, matching packet means how to configure the ACL commands to look at each packet and identify which packet to be discarded and allow. Taking action when a match occurs. We have one or two actions to be chosen: deny and permit. Simply, they mean discard the packet or allow it to keep going as if the ACL didn't exist. Next one is matching logic and command syntax. So each ACL has access list command like this, and number is from ranges and one number is no better than the other. Each access list command shows permit and deny, like this. So, how to match IP address? It is easy. To match a specific IP address, we just need to type IP address at the end of the command. So the second picture shows the ACL number 1 and permit IP address in here. However, if you want to match the exact full IP address, what should we do? Put full in front of IP address? No, we just put host keyword. And later iOS versions, when we put host keyword, iOS accept the command, but they remove the keyword later. So I don't know, but it's very interesting. Next is chapter 3. Advanced IPv4 access control list. Well, extended ACLs different with standard ACL because larger variety of packet header fields can be matched with the packet, and standard ACL can block all data, but it can only block from starting network, which means if I wanted to block to one PC, but I block all PCs when I used 2.2.2.0 bands. Extended ACL can exactly choose starting point and destination, so it can block only PC. And matching TCP and UDP port numbers, the most useful ports to check are the well-known ports by servers. And this picture, we see IP header and TCP header and port number fields. So now this is an example of RFT server and client on the left. Well, I took a while to understand this figure, but it is very simple and nothing to worry about it. This packet sent from the client subnet, and it includes TCP header and packets with destination port 21. Let's see the right side of the picture. What we see is EQ21. To fully match with EQ21 parameters, consider that packets moving from left to right like a picture. And as I said, users are using well-known port 21. The TCP header has a destination port value of 21. And the important part is that position of parameters are also important because the position which identifies the fact that the EQ21 parameters should be compared to the packet's destination port. So, next is named IP access list. Well, we can think that this is the same process as numbering IP ACL. It should filter packets and they can match the same fields as well. So, we have numbered ACL and named ACL. The differences are using names are making easier to remember. Huh? And it is using ACL subcommands, not global commands, to check action and matching parameters. So the picture shows just simple standard ACL number and using 3 numbered ACL commands to create 3 permit subcommands for the named ACL. And this is my favorite part, ACL configuration. So we use IP access list in global config command. Basically, it will define the ACL standard or extended with the name. Also, this command can lead us to get in ACL config mode. We have permit deny and remark commands in ACL access list. So we did IP access list extended Bernie to create ACL. Bernie is just, well, naming here. And next we have permit and deny systems depends on the match. And after that, show running config will output the name ACL config before the single entry is deleted. So, thank you guys for watching my video, and if you guys have any question, as usual, just put some comments. Thank you so much.